denominator, in cascade form, this h of z we arrange in the form of h1z into h2 of z, and this h of z denominator having 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 separate bracket terms. Separate bracket terms means what? It having its own roots. It's having own roots. Okay. How? So you can take the same example, and I think in the equation number two, equation number two, that is h of z is equal to, we consider h of z is equal to 5z z plus zero point 0.4 divided by z minus 0.2 and z minus 0.6. So that is equation number 2. So such transfer function is given. Okay. So here already separate brackets at the denominators are there, means roots are get separated. So it is not necessary to find out the roots and make the denominator with two separate brackets. Okay. Now here you can write h1z is equal to 5z upon z minus 0.2, and h2 of z you consider it as z plus zero point 0.4 divided by z minus 0.6. Z plus zero point 0.4 divided by z minus 0.6. Okay. Now it becomes the two separate entities h1z and h2 of z. Okay. So separately you realize the h1z and h2 of z by using direct form second. So h1z and h2 of z structure drawn using direct form second. Okay, but we know for direct form second the powers require in negative manner. Okay, powers are in negative. So first you consider h1z is equal to 5z upon z minus 0.2. Okay, how to make the negative power? Take the highest power common. So here the highest power at the numerator side is 1, and at the denominator side is also 1. So you take z common. So h1 z is equal to, if you take z common, so inside bracket 5 is remaining. Here you take z common, inside bracket 1 minus 0.2 z inverse, z get cancelled, and therefore h1z is equal to 5 divided by 1 minus 0.2 z inverse. 1 minus 0.2 z inverse. Okay. Same for h2 of z. So h2 of z is equal to z plus 0.4 divided by z minus 0.6. Here the highest power is 1. Here is also highest power is 1. So take z common. So if you take z common here, it becomes 1 plus 0.4 z inverse divided by z common 1 minus 0.6 is equal to 1 plus point z inverse divided by 1 minus 0.6 z inverse. Got it?
Yes, sir.
Now it's very easy to draw the structure by using direct form second. Okay, so here you can use the shortcut method. So H1Z, how to write it? How to write it? Hmm? The highest power at the numerator and denominator is 1. That's why it require only one delay. It require only one delay like this. Okay. Then at the left side, you use poles only. Hmm? The denominator, at the left side. So here the constant with the z inverse is zero point 0.2. Actually, it is minus zero point 0.2. So here you consider negative sign. So minus zero point 0.2 becomes plus zero point 0.2. Okay, it is added here like this, and the constant is 1, and the constant is 1. Okay, and at the right side you use numerator, means all zero system. So here at the numerator only 5 is constant. Hmm? That's why here you can directly write 5. Hmm? So this is x of n, x1n, and this is y1n, x1n and y1n. Okay, then in same way you can realize s2 of z also. Okay, the highest power at the numerator and denominator is 1. Okay, that's why it requires only one delay. At the center you draw that delay, z inverse. Okay, at the left side you use denominator, means the poles. Here the constant is minus zero point 0.6. That's why it becomes plus zero point 0.6. It get added here. Hmm? Constant is 1 like this, x top n. And at the right side you use zeros, means the numerator having constant zero point 0.4. So you write 0.4 as it is without changing the sign. It get added here, constant is 1 again, and this is x y2 of n. This is y2 of n. Okay, clear? So this is h1z, and this one is s2 of z. h1z and s2 of z. So in cascade, you, as the name indicate, so one after other. So you connect this s2 of z to h1z. You connect this s2 of z to h1z directly. So if you draw it separately, here I directly connect this line to this line to this. This become a cascade structure. Become a cascade structure.